Hello everyone, welcome to TV Math Hub. In our today's session, we want to look at question number 10 for Wakisha joint mock. And question number 10, part A says, show that this one here is equal to that. So what is most important here is to know what factorial means. If we are talking about 4 factorial, it is same as having 4 times 3 times 2 times 1. Likewise, someone can write this as 4 times 3 factorial. Likewise, someone can write this as 4 times 3 times 2 factorial. So if you have 4 factorial, you can write it as this. So when we have, for example, n factorial, then it is same as having n times n minus 1 times n minus 2 times up to when you come to 1. Meaning this can also be written as n times n minus 1 factorial. This can also be written as n times n minus 1 times n minus 2 factorial. So we have different ways of how we can write this, but what is most important is to know that when you are dealing with n factorial, then you are having n times, then this value reduces by 1, like the way we have done here. You have a 4 factorial and you are saying 4 times 3. So the 4 subtracts 1, you get 3, 3 subtracts 1, you get 2, 2 subtracts 1, you get 1. So until you come up to this last point. So what are we interested in? We are interested in showing that when you have this left hand side, you'll be able to get the right hand side. So that is our major point here. So we shall first of all consider the left hand side, which left hand side is saying n minus 1 factorial out of n minus m factorial, then m minus 1 factorial plus n minus 1 factorial divided by n minus m minus 1 factorial, then m factorial should be able to give us n combination c. But we must know what is n combination m. N combination m by definition is n factorial over n minus m factorial then times m factorial. So we need to show that this one here, this left hand side, will give us this expression here. So that will be our interest. So what we shall do is we shall say that this expression here is equal to, let us say this expression is equal to, we realize n minus 1 is common, n minus 1 factorial is common, so we shall pull it out, and here we shall remain with n minus m factorial, then m minus 1 factorial plus 1 divided by n minus m minus 1 factorial, then m factorial. That is what we shall have. And this, the whole of this is multiplied by this. So when we reach here, remember our interest is to get this. We shall first of all look at, we realize that we have different expressions in the denominator. So what we can do is we try to get, the common denominator. Let us try to get the common denominator. And as we have seen, in what we are interested in, the common denominator must be n minus 1 factorial m factorial. So we shall try to create this one here in this given expression. So let us first consider 1 upon n minus m factorial, then m minus 1 factorial. So if I want to create this, remember you are showing, so you want to make sure that the whole of this gives you this one here. So in the denominator, I am interested in creating this. So if I want to create this one here and I have this, what can I do? N minus 1 is already there, so that one will have no much impact. So let us look at this. This is m minus 1 factorial, but we need m factorial. If you have a 1 out of 3 factorial, if you have 1 out of 3 factorial and you need 1 out of 4 factorial, you can easily achieve this, because I know if I need 4 factorial, it must be 4 times 3 factorial. So it means I can multiply on both sides, that is in the numerator and the denominator, by 4. And when I do that, it means I will have 4 divided by 4 factorial. So likewise, if I have m minus 1 factorial and I want to create m factorial, I can write this as m times m minus 1 factorial. So when I place this m here, it means it will become m factorial. But because m was initially not there, so whatever I do here, I should do the same in the numerator. So I will multiply the numerator and the denominator by m. And when I do that, I will be able to get m out of n minus m factorial, then m factorial. So I will have achieved this denominator here. So let us also try the same for the second part, this one here. So in the second part, I'm considering 1 upon this one here. So let us consider that. Consider 1 upon n minus m minus 1 factorial, then m factorial. So this, as we said, we want to create in this expression here, we need to create n minus m factorial, m factorial. So looking at this, we already have m factorial. So that one is already there. So we need to look at how best we can create n minus m factorial here. So this is n minus m. To create n minus m factorial, so I can multiply n minus m both in the numerator and the denominator. So n minus that factorial, then m factorial. But if I create n minus m here factorial, likewise I will do the same in the numerator. So I will multiply through by n minus m such that I create here n minus m. So if you have 1 over 3 factorial and you want to create 4 factorial here, so you will multiply both sides by 4. So you will have 4 times 3 factorial, which will give you 4 factorial. So that is what we are doing. So this will be n minus m upon n minus m. Now the whole of this will be, this one here will be n minus m factorial, then m factorial. So we shall have achieved n minus m factorial in the denominator according to what we need here. So next, let us substitute everything back in this equation. We shall call that one equation 1. So in equation 1, now we shall have the left hand side from equation 1, the left hand side will be equal to, remember we have n minus 1, we have this one here, this is n minus 1 factorial out. So we have n minus 1 factorial out. So we shall have n minus 1 factorial, it is out. Then the first part, which is this one here, gave us this. So that is what we shall substitute there. M upon n minus m factorial, then m factorial. The second part gave us n minus m over n minus m factorial, then m factorial. We are substituting in equation 1. So when we do that, then we shall be having this one equaling to this, but where there is this, we are putting this, where there is this, we are putting what we have obtained. Now from here we try to simplify. This is n minus 1 factorial, the LCM is the same, which is n minus m factorial, then m factorial. So we shall simply get m plus n minus m, and this will be same as n minus 1 factorial into this m and this will cancel, will remain with n upon n minus m factorial, then m factorial. So this is what we shall have. So this will also be equal to n times n minus 1 factorial divided by n minus m factorial, then m factorial. But looking at this and what we have been doing so far, should be able to tell that this is actually n factorial, then upon n minus m factorial, then m factorial. So clearly this, when you look at this and what we did at first, so this is actually n combination m. So this is actually n combination m. And clearly you have shown that the left hand side is equal to this, and which implies that you have now shown that this one plus this is equal to this one here. And that marks to the end of our proof.